Welcome to the Janus Project. This is Creation Week. We are going through Bill Nye's book Undeniable, and we're just kind of picking apart little bits from each of the chapters. And so this is chapter 4, and chapter 4 goes into the organizational hierarchy of nature. Now, he goes into a huge discussion of top-down, bottom-up organization and things like that. And he talks about how human organizations have kind of this top-down structure where, you have managers over other things and they kind of control the flow of information. And he says nature kind of builds it from the bottom up. And so he says, in an organization, you sometimes have, kind of the guy on top who everything has to go through, and that really limits the amount that an organization can stretch because he's kind of controlling everything. And this is where I pick up in the book. I want to read this section to you, and then I want to explain it. He says, it doesn't work that way in evolution. If you have a system that holds an organism back and keeps it from reproducing with success, that organism will not pass its genes on to the next generation. I want to pause right there, and I just want to point this out. If you read some of the books that are behind me on the shelf, so Darwin Devolves is one of them, and that's this book right here. You've also got Darwin's Doubt by Meyer. These books are going to dig into some of these issues in a lot more detail. So Darwin Devolves gets a lot into DNA and kind of what we can understand through studying that. Darwin's Doubt is going to kind of dig into the origins of animals and those type of things, dealing with some of the various shales and some of the stuff that Bill Nye is going to talk about later on in his book. And so what these books do is they actually produce this point, that there are times where something that is going to be detrimental to your health in the long run may actually be beneficial in the short run. And so I used the illustration previously that it's like having a flood heading toward the basement of your house. And as you have that flood heading to the basement of your house, what's going to happen is it's probably the best bet to break a hole in your basement so the water flows straight on through rather than wait to get all the parts together to build a pump. And so there are times where animals, because they need to survive in a rapidly changing ecosystem, for instance, that it might be quicker for them to develop a certain trait that helps them survive, but in the long run, it's actually going to be harmful for them. I think of things like you've got sickle cell anemia, which helps you survive things like malaria, but in the long run, it's not actually helpful for you. And so there are certain populations of humans who will develop things like sickle cell anemia because they are in that area where malaria is going to kill off everyone who doesn't have that trait, or most of them. And so that's where it's helpful in the short run, but not in the long run. And so while he talks about this, he's very idealistic, but not realistic. And so what he says is that anything that's going to keep it from surviving well, it's not going to pass those genes on to the next generation, which again, it might still pass them on. Again, but it's not necessarily helpful. It says nobody has to decide anything, although a change in gene usually happens at random. The next generation of that gene is subject to forces that are anything but random. Okay, but if you don't have anyone directing it, it actually is random, because there are things that can still kill you, and unless you've spread that gene through enough of the population that random environmental changes or other accidents won't wipe out the whole genetic population, then actually it may not help you survive in that one instance that you need it to survive in. Okay, so there are times where, let's just use this illustration. There are times where bacterial resistance will arise, but it's because an antibiotic will target a certain organ in a bacteria. And so if that bacteria is isolated in a petri dish or something like that, that bacteria may not have any competition. And so if the antibiotics are killing off all of the other healthy bacteria, the sickly bacteria, which has the one missing organ, may actually survive. And so if that organ is missing that the antibiotic is targeting, that bacteria may survive, but it's not actually healthy. It's not able to actually compete well in the real world. And so once that stimulus, that antibiotic, is removed, Any that survived that had the organ will take back over. You can see this demonstrated again. I'll direct you toward Icons of Evolution. It's a documentary, because the whole idea of antibiotic resistant bacteria is actually not a good evidence of evolution, because typically it's a missing piece. It's something that bacteria had that the antibiotic targeted, and it no longer has that organ or that structure, and so therefore it's immune to that antibiotic. That actually is random. It is entirely random, and it may be helpful, like I said, for the short term, but not the long term. All right, now it keeps going. He says, nobody has to decide anything. Although a change in gene usually happens at random, the next generation of that gene is subject to forces that are anything but random. You've got the right combination of genes, or you don't. You're still in the game or you're not. We call it selection pressure. It determines which genes get through. Many creationists and science deniers, so you see his little shtick again, especially in the United States, cite randomness as part of the process of evolution and go on to insist that since evolution is random, it cannot explain the rich complexity of life. Exactly. Okay? With very few exceptions, what we see around us as things change, it's a result of a loss of information. Okay, that's what we see. We see, here is the full information, and as it adapts to its environment, it's losing certain bits of information. There are times where two organisms will fuse and become a new organism. That does happen kind of on a bacterial level. But this idea of, it's getting more complex, it's really not. What we observe isn't. Okay, now he goes on. He said, this is essentially another form of the thermodynamics argument I talked about in the previous chapter. Creationists often use the example of a hypothetical tornado swirling its way through a hypothetical junkyard whose contents include all the pieces to build one of my beloved old 747s. This is sometimes called the junkyard tornado argument. What are the chances, they ask, that you end up with a perfectly assembled operable airplane? Obviously zero, because it would be random. The problem with this argument is the premise is wrong. Okay, the premise actually isn't wrong. Okay, the idea is you have random chance. Okay, so you, especially when you come with the origin of life theory. Okay, you've got the chemicals there laid out in a primordial ooze. You sometimes have a lightning bolt or something that is causing these inorganic, that means non-living creatures, substances to fuse together in just the right way to make amino acids, to make proteins, to make some sort of DNA or some structure like that, and they eventually form into a very simple single-celled organism. Okay, never mind the fact that simple and single-celled organisms do not necessarily go together. But this idea of you have a random natural phenomena happening to a pile of building blocks is actually pretty spot on. Anyway, it goes on. It says evolutionists and a selection of reproduction worthy genes that drive it is the opposite of random, but it's not. Okay? Because there is nothing actually choosing. You are literally pulling, you're in a casino and you're pulling the slots and seeing what happens. Okay? Because like I said, there are genetic traits, there are characteristics that might be helpful in the short term, but not in the long term. And so there could be a structure developing that could eventually become useful, but it is not helpful in the short term, which means it's probably not going to stay. Okay, so he keeps talking about evolution as it's a sieve that living things have to pass through successfully, or we never see them again. But evolution as a thing does not exist. The process filters life forms out, but that doesn't mean they weren't fit for life eventually. It just means they failed right now. Okay, if I die right now without passing on my genes, which I've done, I have 3 sons, but if I die right now, it might have nothing to do with my genes. It might be because I died because of an environmental change, or a tree fell on me, or some other random thing. Animals are killing each other all the time. And so if you have those genetic traits, they have got to spread through a population extremely fast, or you're in big trouble, because that one that was actually helpful could die off from some other reason. At Boeing, well, any company, there are selection pressures that work quite a bit like natural selection. There is a competition between airplane companies, customers, and airline corporations that buy billions of dollars worth of planes want their equipment to be efficient. But nature doesn't necessarily have to function efficiently. There are all sorts of useless genes, so to speak, buried in my code because the right environmental pressures have not brought them to the forefront. That's what epigenetics is all about. There are genetic traits that are bound up that aren't being used yet because I have not yet reached the point where they're needed. And it might never happen in my lifetime. It might be genes I pass on to my kids, and it could be a disease, it could be something that helps them. But look up epigenetics, because there are times where certain genes are not actually helpful. Or they're helpful, but they're bound up because they're not helpful in the right situation yet. So I just look at this, and he's very simplistic, okay? There's a lot more complexity. He talks about winglets and a lot of things like that, and really he proves the point that nature is extremely complicated. He uses the idea that evolution happened as a reason to prove that it happened. That really is what it comes down to. Ooh, look, this design that we happen to mirror through a lot of work, it's present in nature. Isn't nature amazing? I mean, that's basically the argument for the rest of this chapter. Like I said, Bill Nye spends a lot of time telling stories. He's a good storyteller, but there's not a whole lot there that actually defeats the logic of creation. Okay, and I want to leave you with that. There's just a little snippet here, but I want you guys to understand that as we go through this book, look for the things and say, does this actually disprove creation? Like, even if this is true, even if this is entirely true, we're going to get to this with Archaeopteryx in a few chapters. But as you deal with Archaeopteryx, so what if Archaeopteryx was actually a bird-like, reptile-like creature that had feathers? Is that really such a bad idea? Is that something that could not be possible in creation? No, we'll get there. It's not. But I just want you guys to understand, there's a lot of stuff he throws out that he's like, haha, you stupid creationist, how do you answer this? And it's like, why is that a problem? And so I want you guys to think through this stuff. Okay, this has been another episode of Creation Week here on the Janus Project. Guys, please like this video, subscribe for more, and I'm going to ask you to comment on the videos below. Please let me know what you guys are thinking. Let me know what you guys are still struggling with, and I can direct you to more resources, or I can put out another video and further explain things. Guys, thank you for tuning in, and I will see you next time on Creation Week.